Okay. So for functions, I'm only going to explain the stuff that I know you don't know. First of all, what is a function, right? Why do we need functions, by the way? Like, the thing is, when you do grown-up math, you realize that there's a problem. If I give you a bunch of equations like this, just two of them, and I say when x is 1, what is y? What should you ask me? What's your question?
What is
If I ask
y?
you to, if I ask you to find y when x is 1, what would you say?
There's two possibilities of y.
Yeah, exactly. Which equation do I want you to use? That's why what we do is we name the equations now. We say f or g or h or whatever. Okay? So now instead of saying what is y, I will say what is f of 1 or what is g of 1. So the of part is me telling you what the input is. Okay? That's just me telling you what the input value is. So you don't even need to say when x is 1 anymore because it's obvious. F of 1 means when x is 1. It would be it would be 2 times 1 plus 3, and this would be minus 1 square plus 5 times 1 plus 7. Okay? So that's why we need functions, first of all. Now, there is one idea of functions that is nice to understand. So basically, functions are machines. Okay? They take an input, x value, they do some operations to that input, and then they spit out a y value. Okay? You can, of course, just like you can do it to regular equations, you can plot a function also. It looks the same as a regular plot. So imagine that you were plotting y equals 2x plus 3. Okay? So something that helps a lot is understand, like thinking that f of x and y, both of these things are interchangeable. They mean the same thing. Okay? So this means the same thing as that. Okay?
Hmm.
So y equals 2x plus 3 is a line like this. Okay? Now, that is what a function is. You already know that. What is a one-to-one function? There are three kinds of situations you can deal with. The first is a one-to-one function. For example, this guy. Why is he a one-to-one function? Because for every x value, for every single x value, there is one individual y value. For example, when x is 1, y is 5, nothing else. And 5 doesn't happen for any other x values either, right? This is the only x value that gives you that y value, and this is the only y value you get from that x value. So it's 1 to 1, one x value, one y value. Okay, is that clear?
Hmm.
Let me show you an example of the other case. Many to 1. A many to 1 function is like, for example, this guy, f of x equals x squared. Such a simple function, but watch this. If I make the x squared function, it looks like this, right? Right?
Yeah.
Parabola, you know this, right?
Yeah.
Okay. Now, if you notice that when x is negative 2, what is y? What is y when x is negative 2 in this function?
4.
4. And what is y when x is 2? 4 again. So, many x values, same y value. So, many to 1. Many x values give you the same y value. So, this is called a many to 1 function. Is this clear?
Yep.
We can find out if a function is a many to 1 by using the horizontal line test. But I don't suggest that, honestly. Just think about it like this. If you see multiple x values giving you the same y value, it's a many to 1 function, okay?
Okay.
I guess it's useful. Like, think about it like this. If there is any horizontal line that touches the graph two times or more, it means that there are multiple x values for the same y value, right? So, if you can make any horizontal line that touches the graph more than one time, it is a many to one function. For example, in this case, I cannot make any horizontal line that touches the graph more than once, right? All of these only touch once. You see it?
Yeah.
So this is not a many-to-one function. This is a one-to-one. Over here, over here, I can make a lot of lines, horizontal lines that touch the graph twice. So this is very clearly a many-to-one. By the way, you only need one horizontal line. Okay. So for example, this guy is many-to-one. Even though I can make a lot of horizontal lines that don't touch the graph twice, I can make like a bunch of them right there, which makes it many-to-one. Okay. Just one horizontal line that touches the graph more than once is enough. Got it?
Yeah.
Okay. Finally, we have the last case, which is one to many. This is not a function, not considered a function. Okay. Now, what is this? This happens when one x value gives you multiple y values. For example, this guy. This graph looks like this. You see that for this x value, you get that y value and also this y value. See? For example, when x is 4, y can be 2, y can be minus 2. So for the same single x value, you get multiple y values. This guy is not considered a function. We don't play with these guys at all. Okay?
All right.
They're not invited to the party. Like none of the rules we're going to talk about are going to apply to them because they're not considered functions at all. How can we check whether something is a one to many? We use the vertical line test. The vertical line test, this is important by the way. If you want to forget this, go for it, but don't forget this guy, okay? Vertical line test is, can you draw any vertical lines that cuts the graph more than once? If you can, it is a one-to-many function, no, one-to-many relationship, and therefore not a function. Okay, so if you can draw any vertical line that cuts the graph more than once, it's considered not a function. Okay, so for example, you see all of these vertical lines cut the graph more than once, right? So it fails the vertical line test, which means that it's not a function. Okay, is this clear?
Yeah.
Okay, now let's talk about the other missing idea that you don't know about, domain and range. What is domain? Domain is all allowed x values into a function. So all the x values that you can put into a function is called a domain basically. Okay. So for example, let's say I make a function x plus 3. The graph of this function normally would look like this, right? Just a line that's going upwards, cuts the y-axis at 3, correct?
Yeah.
However, what if I make the same function, but this time I specify that I only want x to be between 0 and 3. This time, the function is going to look a little bit different. So instead of drawing the whole thing, I will only use the part starting at x equals 0 and going up to x equals 3. So we call this the domain. Okay? All allowed x values. So the graph becomes cut. We're only using a part of it. Does this make sense?
Yeah.
Okay. That's basically the idea. What about range? What do you think? Give me a guess. Domain is all allowed x and x values. What do you think range would be?
Not all allowed.
No, no. All possible y values.
Uh,
Right? All the outputs you can get from the function. By the way, you notice that this is x values, right? Because I'm talking about the x-axis. You see?
yeah.
From 0 to 3 on the x-axis. Similarly, if I make a function like x plus 3, this guy looks like a straight line. The thing is, this straight line never stops on both ways because I haven't specified a domain, right? I haven't cut the graph. So this is just forever. So what do you think the domain is in this case? Y can be between what? So what's the lowest possible value that Y can go to in this graph? It's minus infinity, isn't it? Because it keeps going down, it never stops. This graph is never stopping. I never told it to stop anywhere. So the lowest possible value of Y is minus infinity. It never goes down, never stops going down, right?
Mm-hmm.
Okay. And what's the highest possible value? Again, it never stops going up. So what do you think the highest possible value is?
Infinity.
Infinity. Never stops. That is the range of this function. Okay. But all functions don't do this. All functions don't just keep going forever. For example, look at this humble guy. We've seen him so often, but look at him now. It's just a regular parabola, but you notice something. What's the lowest possible value that Y can be in this case? Is it minus infinity? Or does the function stop going down at some point?
Stops going down.
When? At what Y value?
0.
Exactly. So Y is always more than or equal to 0, and what's the maximum value?
Infinity.
Infinity. Never stops going up, right? Let's look at the example we had earlier. So, if we look at this function, normally, of course, if we didn't have this restriction, the graph would have a range of minus infinity to infinity. But because of this restriction, there is now a minimum value and a maximum value of Y. You see? So, what do you think the minimum value of Y is in this case? That would be this, right?
Yeah.
What is that? This is the function, by the way. What is X over here? What is the value of X at this point?
0.
0. So how do you find the corresponding Y value?
Um, 0 plus 3.
Yeah, which is 3, or the Y-intercept. So the lowest possible value of Y in this case is 3, instead of minus infinity, because the graph stops here. And what's the highest possible value? How do I do that?
Uh,
About the highest possible point, do you know the X value?
yeah, it's
So
3.
okay, yeah, so plug in that X value into the function to get the Y value.
6.
Exactly. So the highest possible value of Y would be 6. So you see, restricting the domain manually actually restricted the range automatically also, because when you cut the graph, of course, you're cutting it off in the Y also, right? You see what I mean?
Yeah.
So this is the idea of domain and range. That's basically all the things you needed to learn about functions, but let's do a quick question. Okay. We also need to talk about how domain can get restricted due to algebraic laws. There are two situations that actually cause the domain to become restricted automatically. Like you see over here, I chose to make x between 0 and 3, right? That's my decision. I could have made it anything. But sometimes a restriction happens on the domain that is caused due to algebraic laws, not because of me wanting to make a restriction. There are two things to be careful for. Number one, never divide by 0. Number two, never put a negative number inside a square root. So you cannot do both of these things, okay? So always stay on the lookout for these two. What do I mean? For example, let's make a function 1 over x plus 1 or x minus 1. Do you agree that x can be anything it wants, but x absolutely cannot be 1? Why do you think that is? Why can x not be 1?
Two would just be
If x becomes 1, what does the denominator become?
zero.
Exactly. And what's the rule? Never divide by 0. That is why x can never be 1. Okay? So this is a domain restriction. X can be anything except 1. Okay? So the domain of this function is automatically going to be all real numbers except 1. Okay? And how do I do this, like, kind of completely? You just have to check, when is my denominator equal to 0? Answer is when x is 1. So you will say that, okay, never make x 1, because if you make x 1, my denominator will be 0. I don't want that, right? Is this clear?
Yeah.
Are you sure?
Mm-hmm.
Okay. That's the first situation. The other is never put a negative number inside a square root. What do I mean? Let's make a new function. You have this function now. The thing is, 4x minus 2 can be anything, but it always has to be above or equal to 0. It can never become negative. Do you agree? Because this thing can never be negative. It's impossible because I can't square root a negative number, right?
Yeah.
So I make a requirement that 4x minus 2 has to be more than or equal to 0. So I will solve this inequality by adding 2 to both sides and then dividing by 4 on both sides. And I will find out that x has to be more than or equal to 2. So the domain is all real numbers more than, so x is more than or equal to 1 over 2 basically. Do you see?
Mm-hmm.
So is this clear?
Yeah.
Never allow the denominator to be 0. So for that, check when the denominator is 0 and then say that don't let x be that thing. Okay? And secondly, never allow the inside of a square root to be negative. So check, kind of set up this requirement that 4x minus 2, the inside of the square root, has to be more than or equal to 0. And that's it. So I'm going to leave some questions for you to try out from this idea. Uh, so you see how it says state which values must be excluded from the domain. For example, in this case, what value of x can I not put in this function? What do you think?
Into um -1.
Negative 1. How do I do that? Simply set the denominator to be 0, find the answer, and say, okay, don't let x be this. Okay? Because I don't want the denominator to be 0. Okay? For example, what should x not be in this case?
0.
0. Yeah, exactly. What about this one?
Still 0.
Exactly. What about this one? Remember, the inside of a square root has to be more than or equal to 0. So can you solve that inequality and tell me the range of x that it has to be?
X has to be more than greater than 2.
Exactly. So what can x not be?
Less than 2.
Exactly. Not less than or equal to, only less than. X cannot be less than 2, okay?
Hmm.
Good. So you understood the idea. I'm gonna mark some questions for you to do. Obviously check your answers once you're done. So this one, this one, this one, this one. Okay. So these are the questions I want you to try out. And about domain and range, this is a good one. So in this question, this is a function. This is its domain. Okay. So this is what you've been told, and you need to find the right answer out of these for the range. Okay.
Okay.
Do you get it? Like for example, if this is your function and this is all the x values that you've allowed, so x can only be -2, -1, 0, or 1, nothing else. Okay. Um. Oh. Oh. Okay. Okay. Never mind. So this is your function. What would the range be if this is the domain, basically? What do I mean? So if x can only be -2, -1, 0, or 1, and f of x is 2 minus 3x, then the only outputs are when x is -2, the output would be 2 minus 3 times -2, which is 2 plus 6, which is 8. When x is -1, the output would be 2 minus 3 times -1, which would be 5. When the x is 0, it's going to be 2. When x is 1, it's going to be -1. So this is the range. This list of values is the range, basically. You see what I mean?
Yeah.
So I want you to try out. This is a very confusing question. I think let's skip it for now. But I want to do this together. Exercise for next class. But if you want to try, for example, you can try to do this one. So like this whole thing. You want to find the range for this case and for this case, okay? And that's basically it, okay? So if you want to try this, you can try it. And that's basically it, okay? That's all I want you to do. We're basically done with functions also now. So I'm gonna send you the quadratics video. I want you to watch that before our next class, okay?
All
And
right.
I'm gonna give you some homework from that too. Don't worry, by the way, the homeworks are gonna become much lesser once this week passes. There's just quite a bunch of things I want to kind of work on before this weekend's. So just try to keep up. Okay. So from the quadratics, I'm gonna put some of these up. One second. You will understand what you need to do when you watch the video. So for this, make sure you remember the vertex form part in the video. Okay, for this thing. Let me stop recording.